Hello friends and followers, and welcome to my channel. In today's video I will discuss the QualityWings AVRO power plant, and as usual it's gonna be a brief description. I will discuss the engine's instruments and controls, and then I will show you step by step how to start the engines. The engine's power are controlled by 4 thrust levers. Each lever has a fuel cutoff switch. Sometimes it's called thrust lever trigger. This allows the lever to be moved into idle detent during the engine start and enables the fuel supply to the engine. To operate this switch, we need to right-click on the switch, and as you can see, this will move the lever into idle. A second right-click will bring the lever back into fuel cutoff detent. Here the lever is locked and you can't move it without releasing the thrust lever trigger. Similarly, when the lever is beyond the fuel cutoff detent, you can't move it back to the fuel off detent without being released by the thrust lever trigger. The thrust power is normally controlled by moving the thrust levers between idle and maximum position range. Thrust levers can be moved manually or automatically by the servo motor controlled by the auto throttle system. When on the ground, the auto throttle can be engaged at takeoff start, provided that the auto throttle switch is armed and toga mode is engaged. The way typically toga mode is engaged is by increasing first the N1s manually to any value between 50 and 60%, and then clicking the black solid circle on the mode control panel. Then auto throttle engagement can be confirmed by the green AT annunciation on the PFD. In flight, the auto throttle can be engaged provided that the auto throttle is armed and either thrust or flight level change or VNAV mode is selected on. Each engine has 2 independent ignition systems for fuel ignition. One system is labeled ignition A, the other one is labeled ignition B. The ignition controls are located on the overhead panel, and they consist of a single ground ignition switch located in the aft left corner of the overhead panel, and 2 continuous ignition A and B switches located in the engine start control panel. Ground ignition switch is used for ground starts, and normally a single system A or B is selected before engines start. Usually the 2 selections are alternated on subsequent engines start. This procedure enables pilots to detect a faulty ignition system if an engine fails to start. Other than A and B selections, this switch has additionally a center position labeled both. This selection is used to arm both A and B igniters to ensure a good start in extreme cold weather conditions. The selected igniters is signaled to operate when the engine switch is selected to start and de-energized automatically when the engine reaches 40% N2. We're gonna see this later on when we discuss the engine's start procedure. When the continuous ignition switches are selected on, igniters are energized continuously. Normally the switches are selected off. However, if the runway is contaminated or flying through areas of severe turbulence or heavy precipitations, continuous ignition A or B must be selected on to protect engines from stalling or flameout. N1 targets for takeoff, climb, and go round are computed by the Flight Guidance System FGS in conjunction with the Thrust Rating Panel TRP. TRP is just an interface that pilots use to select the thrust ratings and put the required data for FGS and FEDEC computing and displays. TRP consists of 2 knobs, 3 thrust mode switches, data display, and master N1 switch. The outer rotary selector has 5 different selections: N1, temperature, V1, V cross, and V dot. V speeds will be covered in other video. The display shows always the value related to the current selection. For instance, the outer selector is set to N1 and the display shows a current computed N1 value of 94.6%. The way typically the two knobs are used is that first we select the data type to be set or adjusted on the small window using the outer rotary selector. Then we adjust the required data value using the small knob. Toga switch is used to select the toga thrust limit, and we have two options, max or reduced. Selecting max will set the target N1 to a maximum rated engine thrust for existing temperature and altitude. Selecting reduced will set the toga N1 to a standard thrust reduction below maximum rated thrust when full thrust is not needed. This will extend the engine life and reduce the maintenance costs. When the aircraft is on the ground and electrical power is being established, toga max is the default setting. Moving the outer rotary selector to temp, the sensed outside air temperature will be displayed in the small window. And if it's not correct, we can adjust it to the correct outside air temperature value using the small knob. To produce a flexible reduced takeoff thrust, we first select reduced toga, then we move the outer rotary selector to temp, then using the small knob we can set the flex temperature to any amount higher than the ambient. Should an engine fails, MCT switch is selected to produce a maximum continuous thrust. After reaching the thrust reduction altitude, a climb thrust is selected to normal. However, if the rate of climb falls below 1000 feet per minute, we select max climb for a maximum climb thrust. When climb thrust is selected on the TRP, all the N1s are synchronized to the N1 of the master engine as selected by the master switch on the TRP. The master engine can be the engine number 1 or 2. Selecting of any thrust mode on the TRP will provide the N1 reference to N1 set display on the primary engine's display. And the TRP N1 and the N1 set values must be cross-checked. Each engine is equipped with DC electrical starter motor for ground starting. The starter motor is powered from a DC start bus which receives a DC current from TR1 and TR2. A single AC power source is used to supply both TRs. This AC source can be the APU generator or external AC or engine-driven generator when using cross-start. To protect the engines during the start, we must ensure that only a single AC source is connected and the other ones are selected off. DC start bus has an on and off start master switch located on the engine's start control panel on the overhead panel. Selecting on will power the DC start bus. The engine start motor is controlled by an engine start switch located also on the engine start control panel. When the DC start bus is powered, selecting engine start switch on will operate the starter motor. The logic sequence to initiate the starter motor operation is first we select a single AC power source, for example APU. Then we select start master switch on to power the DC start bus. Then finally we select the engine start switch on. More details on the engine's start will be discussed later on in this video. To start an engine in flight, the airflow through the engine will be sufficient to initiate the start. Let's have now a brief overview on the engine indications. A primary engine display PED located on the central panel. 4 identical indications are arranged in 4 columns. 1 column for each engine. Engine indications consist of a triple gauge oil indications for each engine engine vibration level in inches per second, N1 set target, fan speed N1 in percentage of maximum fan speed, exhaust gas temperature EGT in degrees Celsius, gas generator speed N2 in percentage of maximum core speed, fuel flow, fuel used quantity, fuel quantity on each tank, pull set N1 rotary knobs, push fuel used buttons, reset buttons. Target N1 as computed by the FGS is displayed in the N1 set window and as an amber command bug on the N1 gauge. The N1 value depends on the flight phase and the thrust mode selected by the pilot on the TRP, as I talked about earlier. This value can be set automatically according to the TRP inputs, or it can be set manually using the pull set N1 knob at the bottom of PED. This knob is by default in auto position, and if we click it, this will simulate a pull set N1. In this position, we can set the N1 target manually by rotating the knob with the mouse wheel to the required N1 target value. When the target is set manually, a letter M appears in the N1 set window as a reminder to the pilot. Actual N1 is indicated by a green pointer. When actual N1 matches commanded N1, the pointer lies within the command bug. When no fuel flow is present, the display shows KGS or LBS, depends on the aircraft configuration. After engine start, KGS is replaced by fuel flow digits. When push fuel used is pressed, the display shows fuel used for a few seconds, then reverts to fuel flow. The fuel used counter may be zeroed with the reset button, but will automatically revert to zero after 20 minutes with the aircraft being without electrical power. Let's see now how to start the engines. The first engine I'll begin with, I'll go through the start sequence in details, then I will jump to the after complete engines start to show you the actions to take after to complete the start procedure. In this demonstration, I'll be using the APU for engines start, and before we initiate the start, we go to the bleed air and air conditioning panel and check that both packs and APU air switches are selected off. Now I go to the lights and notices panel and select the beacon on. On the fuel panel, I'll turn on the AC fuel pumps. On the electrical panel, I will check that only the APU generator is connected to the electrical system and all the remaining AC sources are selected off. Ground ignition will be alternated from system B to system A. Thrust levers are checked for fuel off detent. Park brake is set. Engine NDIs are selected on. Start master switch select on. Start power on, annunciator light up, confirming that our DC start bus is being energized. Now the start rotary selector is used to tell FADEC which engine we want to start. So we have to decide first which engine we want to engage the start switch. For instance, I'm gonna start the engine number 1. So start select to number 1. Engine start switch select start. Starter operating and engine ignition A on, lights come on, confirming that both the starter motor and the ignition are signaled to operate. Now we need to monitor our engine instruments starting with the N2. When N2 reaches 10%, we introduce the fuel to the engine by moving the thrust lever number 1 to fuel on detent. To do so, we need to right-click on the thrust trigger switch, fuel on. The N2 is accelerating toward 20%, at which the fuel ignition take place, and this is confirmed by KGS being replaced by fuel flow and EGT rising. Movement in N1 checked. Oil pressure showing a rise into the green range. At 40% N2, both ignition and starter motor are checked off. Finally, we look at the engine indications to check if they're stabilized at idle. This completes the first engine start sequence. Now we can proceed with the next engine start by following the same procedure. Let's now see the procedure we follow to complete the full engines start procedure. Now, as you can see here, all engines are started and stabilized. Now we go back to our engines panel and we set start, select to off, start master goes off, and finally we turn off the engine's anti-ice switches, and this completes the QualityWings AVRO engines start procedure, and see you in the next tutorial.